Hey guys, my name is Mike, and this is Math Tutoring with Mike. Hey, before we jump into our video, there are just a few things that I would like to review with you. The first thing is that I want to implore that at the end of this video, by the time that you reach the end of this video, I want to make sure that you understand the principles that we went over today in this video. So if you have to stop the video at any point in time, that you're confused, or if you have to rewind, I really want to suggest that you do that. The second thing is that after you've reached the end of this video, that you actually go back and try solving the example problems on your own. Doing this, I find, is very important with cementing the theories and cementing the understanding, that you actually understand what was reviewed. So, thirdly, chances are you came to this video with a specific problem that you had. If at the end of this video you realize that I have not addressed the specific problem that you are looking to solve, I invite you to leave me a comment or shoot me an email with your specific problem or specific question. And you have my word, I'll do my best to either preparing another video or reaching out to you personally how to solve that particular problem. Anyway guys, so on to our video. In this video, we shall be taking a look at how to convert decimal numbers into fractions. So we'll be identifying how to convert a number like, for example, 0.3 into 3/10, or possibly 0.4 into 4/10, or 2/5. Okay, so let's take a look. First thing we'll do is we'll start with a decimal overview. That'll be great for our background. So if you recall that in a number 1, 2, 4, if you recall in the number, particularly this is the ones place, tens, hundreds. Okay, in the same way, this number here, number 1, is in the place that's called tenths. This 2 is in a place called hundreds. And then this 4 is in a place called thousands. And it goes on, tens, hundreds, thousands, 10,000s, 100,000s, so forth, so on. And then the next way, numbers going this way, it's the ones, the tens, hundreds, should be hundreds, thousands, 10,000, 100,000, million. Okay, so this is important for us. This information is important for us in converting a decimal number to a fraction. Okay, so in knowing that now, let's look at a common example that we had just a minute ago, 0.3. Why is it 0.3 when converted 3/10? Well, if we look at the place of this number here, the place of the 3 is in the tenths place. So what does that mean? That means that we can put that number 3 and then over a 10 value. If we had, for example, a number 0.32, we can look at this value and say that the highest value, or this value is the tens, this value is the hundreds. So the lowest place value in this decimal number would be the hundreds place. So why is that significant to us? Is because we can then now take this number value of the fraction, 32, and put it over 1/100ths, because this 2 value is in a hundreds place. Similarly, if we have a number such as, say, 0.516, and we can identify that this is the tens place, this is the hundreds place, and this is the thousands place. So this number then will be converted to 516 over 1,000. Okay, so this is a pattern that we're seeing. Okay, if we continue on, we see that this number, what if we look at this number, 50104? Okay, let's apply the same principle here. Tens, hundreds, thousands, 10,000s, 100,000s. So then this number then would convert to 50104 over, did we say 10,000s? Tens, hundreds, thousands, 10,000, 100,000, sorry. Okay, this is how we then convert the decimal number now into a fraction. In some instances now, we may need to simplify the fraction that we just found. How then do we simplify the fraction that we found? So if you recall, maybe you didn't get a chance to watch it, but I have a video there that actually shows you how to simplify fractions. We're going to use that theory now of simplifying fractions. Okay, so once again, we have a decimal number and we convert it to a fraction. We see that that fraction is 3/10. Okay, now let's figure out, is this in the simplest term or not? In the video, I showed you that one approach to doing that would be to find the greatest common factor. And what that would entail is we would want to find all the factors for the 3 and then all the factors for the 10. Okay, so finding all the factors would mean what two numbers, we want to find all versions of two numbers that would equal to 3. And we see that there are only two numbers that are factors of 3, such as 1 and 3. And 10, we see that it's 1 times 10, 2 times 5, and that's it. 1 times 10. And so all the factors of 3 are 1 and 3. All the factors of 10 is 1, 2, 5, and 10. Next, we want to circle all the numbers that are common between the 3 and the 10. So we see that except for the 1, there are no other numbers that are common. So that means that the 3/10 is in the simplest form. Let's look at another example where we would have to simplify the decimal that we converted from a fraction. Okay, so we take a look at this that we converted from a decimal point. Let's say we have a decimal point, 4.4. Okay, so to convert this decimal into a fraction, this 4 is in the tens place, so the fraction becomes 4/10. Now we have an answer. Is our fraction in simplest terms? Now we need to simplify it. Okay, to simplify, we want to get all the factors of 4, and we want to get all the factors of 10. So let's do that now. Factors of 4 are 1 times 4, 2 times 2. Okay, so then all the factors of 4 are 1, 2, and 4. All the factors of 10 again is 1 times 10, 2 times 5. So all the factors of 10 now are 1, 2, 5, and 10. Next, we want to circle now all the common factors except 1. All the common factors between the 4 and the 5. We see that what's common is just the 2. So 2 is common in both 4 and 10. So now what do we do with this 2? We go back to our fraction and we say 4 divided by the greatest common factor. Okay, so we said that the greatest common factor would be 2 because it's the largest. 4 divided by the greatest common factor that we just found. And then 10 divided by the greatest common factor that we just found. 4 divided by 2 is 2. 10 divided by 2 is equal to 5. So what we just found is that 0.4 when converts to a fraction 4 over 10. We found it here. And then 4 over 10 when simplified equals 2/5. So we can take this approach every time. Every time we can take this approach. Let's look at a bigger number. We may have a challenge with a bigger number, but let's take a look at it, shall we? So let's say we have the number 0.41 divided, 0.41. And we want to now convert this into a fraction. Converting this into a fraction now would mean we have the 4 in the tens place and the 1 in the hundreds place. So it would mean that converting this into a fraction would then be 41 over 100, because the number furthest to the right is in a hundreds place, and that dictates what we see as our divisor or in our denominator. Okay, is this number in its simplest term? Let's take a look. We want to find all the factors of 41. All the factors of 41 is really 1 times 41, because I believe 41 is a prime number. That's just for a separate topic, but there's only 2 numbers that can divide into 41, and that's 1 and 41. If we look at 100, you can see 100 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10, and that's it. So all the factors we're going to list out again. Different color. For 41, it's 1 and 41. For 10, it's 1, 2, 4, 5, 10, 20, 25, 50, 1,000. And you'll see that, with the exception of 1, there's no other factor between 41 and 100. So what does that mean? It means that 41 is in fact in its simplest terms. So no need to simplify any more. What happens when we get a big number as our decimal? So for example, we see 0.352. Let's do this example, 352. So the number to the furthest, the number to our right is in the tens, hundreds, thousandths. So that means that when we convert this fraction, it would be 352 over 1,000. Sometimes we may have a special case where we're trying to find or we're trying to simplify a big fraction that looks like this. We can apply the procedure that we talked about earlier in finding our greatest common factor, and that is if we listed out each of the factors for both the 352 and the 1000. But we may find that that's a bit tedious because we would have to find the method that we use. We said find all of the two values when multiplied together would give you 352. So that method can work here, but with the number being so big, we may find that that method is a bit tedious because we would have to go through and identify all the scenarios. Like, for example, we would have to identify can 2, what number when multiplied by 2 would give you 352. Same thing with 3. We'd have to ask the question, and then we would have to go through all of these steps to find out what two numbers, or find out all of the numbers, what two numbers when multiplied together will equal 352. So I just want to introduce or show you a simpler way of doing this. I find this way is very simple, and this method is actually called the prime factorization method. Okay, and the prime factorization method is simply this. Why don't we do a simple one? Keep in mind that we are looking or considering all of the prime numbers in the prime factorization. Let's look at this example. Okay, 12 over 24. Okay, so what we would do is we would find all the prime factorization for both the numerator and the denominator. Okay, so let's look at 12 first. We would ask the question, what two numbers, so we would look at 2, right? We would say, is 2 divisible, or can 2 go into 12? And if so, what number when multiplied by 2 would give you 12? And that number would be 6. Okay, so then we would continue looking at this number here, and we would continue extending, because this number here, we're assuming that this number is a prime number, and this number cannot be broken down any further. So we're just using prime numbers here, okay, guys? So now we look at the 6, and because we're going to keep looking at 2 until we can't divide 2 any longer. So you know that 2 times 3 is going to equal to 6. Okay, so 2 is okay, so we no longer consider for 2. Now we ask the question, well, we know that 3 is a prime number, so that's it. Okay, so that's the prime factorization for 12. Now let's look at 24. Prime factorization for 24 is we look at 2, the lowest prime number, let me say 2 times 12 equals 24. Okay, so this number is all set. We now have to continue on to 12. We considered the lowest prime number again, which is 2. And we say 2 times 6 is 12. Okay, we finish with that number, and we continue on with the 6, because the 6 is not a prime number. Okay, so we continue on, and we ask the question, we considered the lowest prime number again, which is 2. And 2 can go into 6. We say 2 times 3 is 6. Okay, so now we're all set, because now all of the numbers in our tree here are all prime numbers. Okay, so once we finish now with both numbers, we now want to identify what's common in both. And I'll circle it with our blue marker here. You see that this 2 here is common with this. This 2 here is common with this. And this 3 here is common with this 3. And so you find that our prime, our greatest common factor is going to be 2, so there's 2 times 2, there's 2 times 3, okay? So what was common in both of those? 2 times 2 times 3, okay? And the answer is 12. So 12 is common in both the 12 and 24, and 12 is our greatest common factor, okay? Now, how do we use this 12? How do we use this 12 again in simplifying our fraction? Well, what we say is we say now this 12 divided by the greatest common factor divided by this 24 divided by the greatest common factor. And that would equal to 12 divided by 12 over 24 divided by 12. And then the answer would eventually be 1 over 2. And this is why when 12 over 24, if you break it down further, 12 over 24 would equal to 1/2. Okay, so now let's take this method and let's apply it to a big number, because that was the intent of showing you. The intent of showing you is just how to use it now for a big number. Okay, so we got 352 over, I think it was 1,000. That was our number here. Okay, so we look at first of all 352. Okay, 352. And consider all the prime numbers. Remember, prime numbers are 2, 3, 5, 7. Okay, so we want to consider the lowest one at first. So 2. Can 2 go into 352? And you'd find that the answer is yes. And go 176 times. Okay, this 2 is a prime number, so no need to consider that extension of the tree. So now we figure out the 176, because the 176 is not a prime number. We continue on with the 2. Just ask ourselves, can 176 can 2 go into 176? If so, how many times? Well, 2 times 88 would equal to 176. Okay, 2 is our prime number, so no need to consider that extension of the tree. And then we continue on. We continue on now. We're still considering the 2 until we can't consider it anymore. Okay, so 2 goes, 2 times 44 will give you 88. This is a prime number, so we're good with that. 44. 2 times 22 is equal to 44. It's a prime number, so no need to consider that further. And then 2 times 11 is equal to 22. And look, we see 2 is a prime number and 11 is a prime number. So we're finished. Okay, we're finished with the prime factorization for 352. Now, let's consider, let's do the same thing now for the 1,000. 1,000, okay? So, once again, we're going to use the same procedure. And we're going to start with the smallest prime number, which is 2. 2 can go into 1,500 times. So 2 times 500 is 1,000. Okay, this is our prime number, so we're good with that. 2 go into 500 250 times. Okay, 2 times 250 is 500. This is a prime number, so no need to consider that. Now, 250, yes, 2 can still go into that. 2 times 125. Okay, this is a prime number, so we're considering that. Okay, we say 125. Can 2 go into 125? The answer is no. Okay, so now we want to consider 3. Can 3 go into 125? The answer should be no. Okay, 3 cannot go into 125 without a remainder. Okay, can 5 go into 125? The answer is yes. 5 could go into 125 25 times. So 5 times 25 is equal to 125. Okay. And then we want to say this is a prime number. Oops. This is a prime number. 25 is not a prime number, so we can continue on. 5 times 5. Okay, and we see here that we have both prime numbers at the end of our tree, so we can stop. Now, we want to identify what's common in both. And we want to say the greatest common factor then will be the product of what's common, okay? So the greatest common factor is 2 times 2 times 2. And we see that there is nothing else common in them. There's nothing else common in them. So the greatest common factor here is 8. Okay, so now what do we do with that 8? I'll show you on the next page, okay? Just keep in mind the greatest common factor here will be 8. So now what do we do with that 8 is we say 352 divided by 100. And this is all with the effort this is all with the goal of just simplifying this fraction here. And we said our greatest common factor was 8. So what do we do now is we take that 8 and we say that we divide both the numerator and the denominator by the greatest common factor. Okay. 352 divided by 8 is 44. And 1,000 divided by 8 is 125. So 352 over 1,000 is simplified to 44 over 125 in its simplest form. So this is just a trick of how to use prime factorization to simplifying bigger fractions, or fractions that seem more tedious than doing the first method that we reviewed or went over in simplifying a fraction. So you've made it to the end of the video. Good deal. I really hope that you understood what was reviewed today. Like I said earlier on in the video, I really think it's a good idea that you go back and try to solve the example problems on your own. That way you can prove to yourself and you can help assure that you actually understand the problems. Well, until next time, with another tutoring session, another math tutoring session with Mike. See you guys.